Hello and welcome to this online session. So today in this online session, we are going to discuss about Cambridge A-level mechanic question paper. This mechanic is a part of mathematics and I have chosen the question paper from 2024. This is your October-November session, right? And I want to tell short detail about this examination. The duration of the examination is 1 hour 15 minutes. Of course, it is clearly written in front of you. And I want to share a short detail about this question paper. So for this examination, you will be getting your one formula sheet and total mark is 50 marks. So this paper contains total of 50 marks and all the marks you will find near to the questions which is written in the square bracket. So I hope all of you are ready with your pen and paper. Of course, I'm going to tell you the step-by-step solution and you can go through, and the entire solution with PDF is already given in the description. You can find out, and if you still anything, if you want, you can write in the comment box and definitely I will answer to your queries, right? So let us go to question number 1. Yeah, so this is your question number 1 and it's of course written here. You can go through these questions and we'll read the question together, then we'll understand what exactly it is asking, then we'll go for the step-by-step solution, right? Now let us see what the question exactly it is telling. The velocity of a particle moving in a straight line at a time t second after leaving the fixed point O is v meter per second. The diagram shows velocity and time. The diagram shows a velocity time graph which models the motion of the particle starting from time 0 and it goes to till t, right? So, and here in the question, it is given that the particle accelerates from the rest. That means it starts accelerating from the rest to a speed v meter per second. So this is the maximum velocity, v meter per second, for 4 seconds, right? Then again it starts decelerating, negative acceleration, and the value is given how much? At 5/3 meter per second square to the instant period. Okay, the detail is given here. Now let us go to see what exactly it is asking first. So first point, we have to find out, what we have to find out? The velocity v. Okay, if I take you this, so we have to find out the velocity v here, right? So to find out velocity v, we can use Newton's first equation of motion, which is v is equal to u plus at. So if I tell you about this v is equal to u plus at, where can I take the initial velocity here and final velocity is here? If I take these two relationship, okay, and in the question it is given that we are given 4 graphs, 1, 2, 3 and 4. 4 graphs are given here. So for this graph, if I take initial velocity here and final velocity here, but we don't know the acceleration is not given here. But in the second case, for this graph, we are given the acceleration 5/3 meter per second. So I want to take the relationship for this graph, right? Now let me show you the solution, right? So I have written v is equal to u plus at. So which implies, so if you see the graph, so initial velocity is v and final velocity is 0 and the time duration is what? 4 to 10, 6 seconds, right? And the acceleration is given negative acceleration. Okay, if we put all the values here, I have written the solution for you here, you can see. So v is equal to, so 0 is equal to v minus acceleration into 6, which is equal to 10. So therefore we got velocity in this graph. So the velocity we got 10 meter per second. So you will get 1 mark here. Now let us go to the next question. So here you have to write the entire working, and this is your 2 marks question, of course. Okay, you will find 2 marks. You will get 2 marks if you write all the correct answers with unit, right? Now in the second part of this question, it is given that given the total distance traveled by the particle from time 0 to time t is 68 meter, find the value of t, right? Now let us go to the solution. I will show you the solution. If you see this graph first, so here time is 0 and the final time is what? T, that we do not know, but the total distance is given 68 meter, right? And remember, I taught you during the class time. So we know that if we are given velocity time graph, in velocity time graph, if you want to get the distance, you have to find out the area under what? Velocity time graph, right? So if I tell you about this graph, so you can see this is one triangle, this is also one triangle, and here also we are given one triangle. So we are given what? 3 triangles. So if you find out the area of all the triangles, then we can find out the distance. Once again, I'm telling you, in velocity time graph, the area under the graph gives the information about distance, right? Now let us see step by step how I have written the solution for you. Okay. In the first case, distance time from 0 to 4, the area of the triangle I have written here, this is 20 meter. In the second case, this is also, I have written trapezium, but it is a triangle. I can show the picture. This is the graph. This is first triangle. This is base and this is height. Of course, the height we got 10 meter per second in the first calculation. So this is 4, this is 10, and you can find out the answer. Similarly, here in this case, the base is 6 and the height is 10. You can find out this area. Now let me show you the solution. Yeah, so after putting all the values, I got 20 meter here and 30 meter here, right? So altogether it is becoming 50 meter, but in the question it is given that the total distance is 68 meter, but in the calculation we got till 50 meter. The next is what our calculation, right? Now look, so the remaining distance is 68 minus 50, 18 meter, right? So can I show you the diagram once again? Yeah, look here. So from here to here we got 50 meter, but from here to till the last is 18 meter, right? So then the distance is what? T minus 10, and the height is given what? -3. If you put all these values, you can find out the time. Now let me show you my solution here. Yeah, the same thing I have written here, and after all the calculation, we got the value is T is what? 22 second, right? So this is the calculation and solution. So now have a look for the entire solution. If it is clear, now let us go to the next question, right? Now the next question. Now the question number 2 is on the screen. Please read the question paper and try to find out the solution yourself. And after that, I will be sharing my solution. Now let us read the question together. A block of mass 20 kilogram is held at the rest at the top of a plane inclined 30 degree to the horizontal. The block is projected with speed 5 meter per second down a line of the greatest slope of the plane. There is a resistance force acting on the block. As the block moves 2 meters down the plane, 2 meters down the plane from its point of projection, the work done against the resistance force, right? So here we have many choice, but I have chosen work energy theory, right? So now let us see the solution. So according to the question, the mass of the block is given 20 kilogram. So initial speed is 5 meter per second. Displacement along the line is 20 meter. Displacement along the line is 2 meter, right? So then the inclination, the angle is how much? 30 degree. Now work done against the resistance force is given how much? 50 joule. That is what I have written, 50 joule. Now if I use the work energy principle, so energy gain